So, I wanted to put together a little video. There's not a whole lot of significance to it. I find it interesting. And it's mainly dealing with inverse functions, because we do have inverse functions with quadratics, but for the most part, most quadratics technically do not have an inverse function. They do have an inverse, but it's not a function. Because for a equation to be or have an inverse, it has to pass the horizontal line test. And most quadratics do not, because all quadratics, not most, all quadratics are a U-shaped graph. So if we drew a horizontal line, it would always cross it at 2 points. It would fail the horizontal line test and does not have an inverse. But, well, it doesn't have an inverse function. It does have an inverse, it's just not a function. So, we are able to make it have an inverse function. It'll still have an inverse, it will make sure it is a function. We just have to set that x is greater than or equal to some value. We could call it d. I don't want to use a, b, or c, because in the general form we do have those there. It's just some number. So it's just x is greater than some number, which will cause the horizontal line test to work. We'll be able to pass it. Now, that number is the x value of the vertex. Try that again. X value of the vertex. Because that's the point where it's highest or lowest, our point where it would actually go from being going up to down or down to up. It is our point here at the top, point here at the bottom, and we could set it to one side or the other. Normally we do in the positive direction, but if we feel like it, we can also do it in the negative direction. It really doesn't matter. All I have to say is that quadratics do have an inverse. Sometimes if we just consider it in all cases where we don't have a restriction on the domain, it's just an inverse, it's not an inverse function. But if we do put a restriction on the domain, it will be an inverse function. Now, I've seen and looked at a lot of different places, and there are many different ways, or several different ways, to find a quadratic function's inverse. But a lot of them are just steps, and it's just, given the problem, we do these steps. A lot of it is completing the square to get there and getting y by itself. But I wanted to go through and show the process to where we can get the general form, an actual equation that we can plug in for a, b, and c, like the quadratic formula. Now, with an inverse, the first thing we would always do is switch our x and y. Because what we're doing to find the inverse, we're switching the input and output of the general function. So we have this here, x equals ay squared plus by plus c. Now, to find the inverse of this general form, we're going to get y by itself. We'd have x minus c is equal to ay squared plus by here. And now we're going to complete the square. And again, there are many different versions of this that do the same thing, and ways that we can do this here, but I want to find the general form. So on the left hand side we have x minus c over a is equal to y squared plus b over ay. And the reason we're doing this here and getting y by itself and then dividing by a is again to complete the square, because we want to be able to rewrite this as a set of parentheses squared. Now to do that, we need this to be a perfect square trinomial. Well, our other spot, I'm going to call it c, it's just the third term on the right side, which is our middle value over 2 squared. In that case, it's b over a. So b over a over 2 squared. Well, it's going to be b over 2a squared, which is b squared over 4a. And we can add it here. But if I add it to one side, we do have to add it to the other, giving us this here. Give myself a little more room. Now that is helpful because the right-hand side is going to become y plus b over 2a squared. And it does always work out that this term is always whatever's the term inside the parentheses before we square it and completing the square. And that is kind of nice, but it works out that way. And there's more, I do have other videos with that going more in depth, because here it's less about that and more about just finding the equation. Now the left-hand side, we do need to get this added together because it's going to be a lot nicer, a lot easier if we had one fraction instead of two. So to add it, we would need to multiply, do that again, that should be a 2, squared 4a squared. I don't know why I did that because I did that before. Is b squared over 4a squared. Sorry, didn't mean to forget that. But we have b squared over 4a squared plus x over c over a. And when we add these together, we get plus 4a x minus 4ac as one whole part. Now again, we're still trying to get y by itself. We take the square root of both sides. And on the right side, the square root and square would cancel, leaving us with y plus b over 2a. And on the left-hand side, we do have plus or minus, because whenever we take the even root of both sides, we have to add the plus or minus. And we have the square root of b squared plus 4ax minus 4ac all over 4a squared. Now, before we start finally getting y by itself, I do want to simplify the radical a little bit. Because the top, our b squared minus 4 plus 4ax minus 4ac is still going to be there. But our 4a squared on bottom, we can take the square root of it and get 2a. And lastly, getting y by itself, we can minus b over 2a from both sides, telling us that y is equal to negative b over 2a plus or minus square root of b squared plus 4ax minus 4ac all over 2a. Or if we want to make this even simpler, we can put it under or as one radical over 2a. And yes, this does look very similar to our quadratic formula, but instead of just having it in terms of a, b, and c, we do have x as well. And that's our formula there. And the nice thing with this is that it really doesn't matter what equation we have, whatever quadratic equation we have, this will give us its inverse. So we could say y is equal to 5x squared minus 7x plus 4 and get this here. And we could go through the process of completing the square in all of our steps. Well, first we would switch our x and y, complete the square, and go through this entire process. Or we can plug it in, because we can say negative b plus or minus the square root of b squared, a negative 7 squared, plus 4 times our a, which is 5, times x, minus 4 times our a, which is 5 still, times c, which is our 4, all over 2 times a. 2 times 5. And now we just need to simplify. Well, our negative 7 is 7. On bottom, 2 times 5 is 10. Inside our radical, negative 7 squared is positive 49. 4 times 5 times x is plus 20x. And negative 4 times 5 times 4 is going to be negative 80. Now again, we can still simplify some. So we have 20x. I like having x, that variable term first. Now our 49 minus 80 will be negative 32 over 10. And we do have this here. Now it's going to be good to make sure nothing simplifies any further. And it's mainly looking at 20x and 32. We're looking for any kind of numbers or perfect squares. Because 20 would be 4 times 5. It does have a perfect square. 32 is 16 times 2. Now we can't quite use all of it because the most we can pull out of both is 4. Because really we're saying 7 plus or minus the square root of 4 times 5x minus 8 all over 10. Now from here in properties of radicals, we can take the square root of 4 out, which is 2. And this here would be its inverse. And this works for any and all inverse of quadratics. Now, I would not extend this to quadratic-like equations. And some of our quadratic-like equations would be x to the 4th plus 2x squared plus 1. It behaves a lot like a quadratic, but it's technically not. Or cosine squared of x plus 2 cosine of x plus 1. It might work with this one here, but I haven't done a lot of testing or seen if it does. So the main ones this equation does work with is quadratics, and I've tried it with a few, and this does indeed give us the quadratic. Now, the only thing I would add is if we do have restrictions that x has to be greater than or equal a certain number, it would be just looking at the final equation and seeing how it looks. Is it going towards the right or the left, the positive or the negative, and then selecting the correct sign, plus or minus, to give us that correct equation that corresponds with the restriction we were given at the beginning. But that's really it. Hopefully that was helpful or insightful. Bye.